8085 microprocessor comes in a 40-pin DIP package. So it has a 40 pins and it has a dual inline package. So let us see the pin diagram of 8085 in this lecture. Now in this section we will study the pin diagram of 8085. So let us focus on the pin number 80 to 87 which are highlighted in the PowerPoint. These are called as multiplexed address and data lines. Means that these pins carry address as well as the data. These pins are from pin number 12 to pin number 19. These are multiplex pins which reduces the pin count. The pin number A8 to A15 are called as higher order address bus. These lines carries only a data. Now here we can see that A0 to A15 is called as a 16-bit address bus, whereas D0 to D7 is a 8-bit called as a data bus or data lines. The next pin is called as RD bar. Now here you can see that pin is highlighted. This signal is used to read the data from the input device or a memory. Whenever this signal is asserted to low, means that if this signal becomes a logic 0, then the address bus will generate an address, and from that address the data will be read. Now the next important signal is called as write signal or WR bar signal. So when I say WR bar, it means that it is a active low signal. This is the next pin which is highlighted within the slide. The signal is used to write the data to the output device or to the memory. So whenever this signal is asserted to low, means that whenever this signal is made as logic 0, the address is generated, and at that address the particular data is written, or the data is written on the particular address of the memory. The next pin is called as ALE, and which is also highlighted within the slide. So ALE stands for address latch enable. As we have discussed earlier, the AD0 to AD7, which are from pin number 12 to pin number 19, are multiplexed. It means that they can carry address as well as they can carry a data, but one at a time. So whenever the ALE is logic 1, that is high, AD0 to AD7 are carrying an address. And whenever ALE signal is 0, it means that AD0 to AD7 lines are carrying a data. The signal indicates whether AD0 to AD7 carries the data or the address. The next pin is called as IO/M bar. IO/M bar means input, output and a memory. So as we have discussed earlier, we have a read and write operations, and those can be performed on input-output devices or memory. Now to differentiate between input-output devices or memory, this signal is used. When this signal is high, it means that the read and write operation is performed on input-output devices. If this signal is low, it means that the read-write operation is performed on a memory. The next signals are called as status signals, and it is a pair of signal called as S0 and S1. Now the combination of these signals perform a different operations, like they indicate that whether the microprocessor is performing a read operation, whether it is performing a write operation, or whether it is performing an opcode fetch operation. Opcode fetch operation means reading an instruction from the memory. So here is a truth table which shows you how these signals are indicated. So whenever S0 is 0 and S1 is also 0, it means that it is at halt operation. Halt operation means the microprocessor is not doing anything. Whenever S0 is 0 and S1 is 1, it means that the microprocessor is performing a read operation. Whenever S0 is 1 and S1 is 0, it means that the microprocessor is performing a write operation. And whenever S0 is 1 and even S1 is 1, it means that the microprocessor is performing opcode fetch operations, which is nothing but it's reading an instruction from the memory. As you know that every computer has a reset signal. Similarly, in 8085 also we have a two kind of reset signal. The first one is called as a reset in bar signal. It means that it is an active low signal. So whenever this signal is asserted to low, it means that we provide a logic 0 for 2 machine cycle. After that, ATT5 will be reset. In this case, only ATT5 will be reset and other peripherals present on the motherboard will be intact. The next signal is called as a reset out signal, and this is active high signal. So whenever this signal is asserted to logic 1 or it is made as a logic 1, then the microprocessor will be reset along with all the supporting peripherals which are present on the motherboard will be in a reset condition. The next signal is called as ready signal, which is also highlighted in the slide. So ready signal is used with the peripherals which are very slow, like memory. So whenever these devices are ready, they indicate that they are ready by using this ready signal. They generate one signal which is received by ATT5 and it shows that the particular device is ready for the data communication, whether it is a reception of a data or whether it is a transmission of a data. Whenever microprocessor wants to transfer a large amount of data from one point to another point, it uses two signals. One is called as a hold and the second one is called as hold acknowledge. A hold is indicated by HOLD and the hold acknowledge is indicated by HLDA. These signals are used by DMA, and that is direct memory access. So whenever we transfer a large amount of data from one point to the point, DMA takes part into that. DMA takes the control of address bus and data bus, which is called as a hold, and in connection with that, processor generates one signal which is called as a hold acknowledge. Whenever a supporting device requires a service from a microprocessor, it generates one signal and that signal is called as an interrupt. So interrupt are the signals which are generated by the external device. These pins are externally available as INTR, RST 5.5, RST 6.5, RST 7.5 and a trap, which are highlighted in the diagram. These pins are connected to the particular devices. Whenever these signals are generated, processor sends an acknowledgement signal which are indicated by interrupt acknowledgement and it is named as INTA. We will discuss all these interrupts in the details in the coming chapters. As we have seen in the previous slides, these interrupts are INTR, RST 5.5, RST 6.5, RST 7.5 and a trap. In this signal, the trap is having the highest priority and the INTR is having the least priority. In this slide, I have highlighted a trap signal and it is an active high signal, and as we have discussed earlier, it has a highest priority in the interrupt structure and it is a non-maskable interrupt. So these kind of signals are used for emergency stop kind of thing.
An 8085 microprocessor has serial communication capability. For serial communication, SOD and SID pins are used as highlighted in the slide. SID means serial input data and SOD means serial output data. VDD and VSS are the power supply pins. As 8085 microprocessor is a TTL compatible, so the plus 5 volt supply is applied to VDD pin of the microprocessor and the ground is applied to the VSS.
The next pins are called as X1 and X2 and this is pin number 1 and 2. A 6 MHz crystal oscillator is connected externally to these pins, that is X1 and X2. Internally, this 6 MHz clock is divided by 2 and 3 MHz of clock is used for a CPU. So our 8085 microprocessor works on 3 MHz clock speed. The next pin is called as a Clk pin and this is clock output pin. Now as you know that 8085 is a sequential device which requires a clocks to run upon. Similarly, the supporting peripherals also requires a clock. So this clock can be provided by this pin. So that if 8085 is working on a 3 MHz speed and other peripheral is also working on a 3 MHz speed, the clock can be provided through 8085. This clock out signal provides a synchronization facility. So whenever a microprocessor wants to send a data to the input output devices or input output devices wants to send a data to the processor, This data will be synchronized as the clock frequency will be remains the same. This slide shows you the pin diagram of a 8085 microprocessor, and next to that is called as a signal diagram. Now the signal diagram is nothing but just an alternative way of showing all the signals present on 8085 microprocessor. Now here we end with the pin diagram of 8085. Thank you.